Hey, this is Mr. Jared, and I want to go ahead and walk you through this explore activity to introduce us to exponents and integer exponents. So what we're supposed to do is complete this table here, and doing that we'll learn what the different rules are for exponents. So let's go ahead and do that. Let's first look at the simple one, starting with 5 to the first power. If we recognize that 5 to the first power is actually equal to 5, and 4 to the first power is actually equal to 4, and 3 to the first power is actually equal to 3, then what should we expect if there is no exponent on top of each of these numbers? There needs to be an exponent, but what would that exponent be? All right, you should have recognized that if there is no exponent, the exponent should be 1. So the first rule you need to know is that whenever there is no exponent, the exponent is 1. So 3 to the first should really be 3, 4 to the first is really 4, and 5 to the first is 5. Also teaches the reverse of that rule, which says that any number to the first power is actually just that number. 5 to the first is really just 5, 4 to the first is really just 4, and 3 to the first is really just 3. So right there, you have two rules. So let's say if we take the number A is really going to be A to the first, and A just represents any number. We also know that if you have a number A and it's raised to the first power, it's really just A. So both rules work back and forward. So let's see what other rules we can identify by following the patterns of this table. If I go from 5 to the first, and they told me that 5 to the second is 25, well, how do I end up with that? Well, 5 times 5 is 25. So when I see 5 to the second, it's telling me that I'm multiplying 5 twice. So really, the most simple way to explain that is that anytime you see an exponent, it's telling you how many times to multiply the base. So 5 to the second would be 5 times 5. 5 to the third would be 5 multiplied 3 times. So 5 times 5 times 5. And if you check that on your calculator, you'll see that you do get 125. 5 to the fourth would be 5 4 times. 5 times 5 times 5 times 5. So let's go ahead and confirm that with the other terms that we have. 4 to the first is 4. So 4 to the second is supposed to be 16. Is 4 times 4 16? Yes, it is. 4 to the third is 64, I'm sorry. So 4 times 4 times 4 should be 64. 4 to the fourth should be 256. So 4 times 4 times 4 times 4, if you check that in your calculator, you'll get 256. The same way with the threes. 3 to the second power would be 3 times 3, which is 9. 3 to the third should be 3 times 3 times 3, which is 27. And 3 to the fourth should be 3 times 3 times 3 times 3, which is 81. So yes, this rule does work. That basically says when you see an exponent, it's telling you how many times to multiply the base. Now let's walk into a more complex process or concept that if you walk with me, it'll make a lot of sense. So let's go back to these fives again. Now we knew that 5 to the first, since it's 5 there one time, the answer is just 5. 5 to the second, it's 5 times 5, which again is 25. But 5 to the third, when I wanted to go from 5 to the second to 5 to the third, we just said that we should have multiplied 5 3 times. But is there another way that we could have gone from 5 to the second to 5 to the third? Well, yes. 5 to the second is 25. 5 to the third is just a third 5. So if I take 25 and I multiply by 5, I do get 125 if you check that in your calculator. So can I follow that same pattern from 5 to the third to 5 to the fourth? Yes. 5 to the third is 125. If I multiply by 5 again, I do get 625. So every time I have an additional exponent, I can simply take the power before that and multiply by an additional 5. So 5 to the first times 5 is 25. 5 to the second times 5 is 125. 5 to the third times 5 is 625. Does that work for the other ones? Let's see. From 4 to the first to 4 to the second is, yes, 4, the original answer, times 4. To go from 4 to the second to 4 to the third, I could take 16, which is 4 squared, times 4, and I do get 64. To go from 4 to the third to 4 to the fourth, I would take 64 and multiply it by 4, and I do get 256. So that works, and for 3, it's the same thing. From 3 to the first to 3 to the second, I would get 3 and multiply it by 3. From 3 to the second to 3 to the third, I would take 9. I'm sorry for that interruption. I can take 9, which is 3 squared, and multiply it by 3 again, and I do get 27. And if I, again, go from 3 to the third to 3 to the fourth, because there's an additional 3, I can take 27 and multiply by 3 and get 81. Now, why is that an important concept to understand? Well, that's because if I multiply when my exponents get bigger, what should I do if my exponents are getting smaller? The opposite of multiplication is division. So if I was going to go from 5 to the fourth to 5 to the third, then I would need to take 625, and this time I would divide by 5. Once I have 125, once I have 125, to go to 25, I would need to divide by 5 again. And I do get 25. To go from 5 to the second to 5 to the first, I divide by 5 again. And 25 divided by 5 is 5. But now that takes us over to 5 to the 0. Now, most of us would assume that 5 to the 0 should be 0. But that's not accurate, because if we follow the same rules that we've been following, if I start with 5 to the first and I go to 5 to the 0, I need to divide by 5. So if I take 5 and I divide it by 5, I don't get 0, I get 1. So if I do it the way that I've been practicing, then my answer to 5 to the 0 should be 1. So does this occur with the other numbers as well? Well, let's see. 204 to the fourth, 256. And this time we're dividing by 4, because 4 is the base. It does give you 64. If you continue to divide by the base to go from 4 to the third to 4 to the second, 64 divided by 4 is 16. And if I take 16 and divide by the base again to go from 4 to the second to 4 to the first, 16 divided by 4 is 4. And if I go from 4 to the first to 4 to the 0, and I divide by 4 again, 4 divided by 4 is 1. So again, 4 to the 0 is 1. With the 3's, 3 to the fourth to 3 to the third, 81 divided by 3 gives you 27. 27 divided by 3 gives you 9. So 3 to the third divided by 3 gives you 9. 3 to the second, which is 9, divided by 3 again, to go to 3 to the first, gives you 3. And if I want to go from 3 to the first to 3 to the 0, again, I have to divide by 3. So 3 divided by 3 is again 1. So 3 to the 0 is also 1. So is there a rule there that we can learn for numbers to the 0 power? Absolutely. Any number, a, to the 0 power will always be 1. So 100 to the 0 power is 1. 152 to the 0 power is 1. Negative 80 to the 0 power is 1. XYZ to the 0 power is 1. Anything to the 0 power is 1, whether it's positive or negative. And we'll continue finishing this with the negative exponents in another video.